Hello, everyone. Thank you so much for joining the webinar tonight. So let me go ahead and share my screen right now. All right. All right. I think we're good. Let me go ahead and change the setting here real quick. All right. So welcome everybody for tonight's webinar. So today we're gonna talk about very interesting things about full large implant planning. And when people talk about full large cases, the first thing come into people's mind is, oh my God, so Flush surgery is so complicated. I mean, there's so much implant, and then there's a different abutment, and there are different criteria, different needs that needs to be fulfilled to in order to proceed, right? So not mention to make the guide for that is, oh my God, this is so hard. So actually, today's webinar is we try to, bring, it is complicated in the end, at the end of the day, but we have different, approaches to make things. We can simplify things to make things easier, to make the surgery as easy as possible. So before we start, if you guys don't know me yet, welcome. So I'm David. I'm the director of guided surgery division at Real-Time Dental Lab. And then I'm also a speaker for diagnostics and real guide planning software. And I am also a KOL for DAS guided surgical kit. So when we talk about, guided surgery, it actually all start with, this little thing right here. I don't know if you guys know about this thing. So there was a very genius doctor, back in the day, back in 90s, and then he just invented a way, so we can, see the navigate through CT scan. That's good. And then how should we, convert our treatment planning into the patient's mouth? So here he is. He just introduced the guided surgery system. His name is Dr. Scott Gans. He's one of my mentor, teaching me a lot of things about what a guided surgery really is. So he has, bunch of publications, and then one of the book he wrote is computer guided applications. That book, I would say that should be the very first book talk about guided surgery, and then that guided surgery textbook has been translated into Chinese. So, so what does that do with me, right? So that actually the doctor translate that and publish that book in back in China was my mentor, Dr. Anderson Sao. So yeah, I got, doctor asked me, hey, David, what is your background? What did you do? So how did you get started? So I actually started as a, social media content creator. So for my, my doctor, so he's actually my mentor that brought me into this field, right? He's a very famous oral surgeon in China. And then I was born and raised in Taiwan, and I, moved to China to work with him. And then, at the very first day of the in the office, I don't even know how many teeth are there in the human mouth. It just, how, this is just how I get started. And then he just brought me in and he asked me to take photos, video for his surgery. And then I tried to put all together his cases. And then he just, taught me how things work, right? And because I was so loved with, the surgery, especially in dental implant. So he just brought me up as a, surgical assistant, to, work with him. And then he has actually has a little booth, we have a, computer guided surgery software, and then 3D printer and dynamic navigation, guided surgery, all that stuff, right? So he just brought all that things together and put me into that situation and taught me how to map in the nerve, how to navigate from CT scan, and this is how I, really get started. And then, about like 6 years ago, I moved to US, and then the first stop I was there in a pretty big lab in California, and then I run a guided surgery division there, running and designing surgical guides for doctors. And then that's where I met my mentor for prosthesis right now for restoration, Dr. Brandon Cover. And I mean, he's a genius when it comes to full arch fix, right? He has so many, invention and great thinking about how to make things easy for, all clinicians. So yeah, so I just, he joined the office in the career prosthodontist, and then he actually owned the lab that called Real Time Dental Lab, right? So we have a lot of talented people there. So I was able to work with them like very closely about how things work. So I have the background about what is how the surgery go, and now I work with three phenomenal prosthodontists, and then I work in the lab as well. So I kind of putting things together in different areas. So allow me, to become who I am today. So today we're gonna talk about, the total overview about what is an Oolong X, right? What is the key, restorative principles for Oolong X, and how should we, apply them into the planning, right? How do we do surgical planning? And then yeah, and then we will jump into live demonstration about how to planning all the full arch in surgical do the full arch surgical planning, and then use a very easy way to fabricate design and fabricate surgical guide to to make the surgery happen. So those are the three phenomenal amazing doctor. They are all prosthodontists. They all so I work with them very closely. So I have the chance, to sit down with them to learn and study how they think, how they plan, and then at the end of the day to see the real surgery happen, and then how they making the planning into the real world execution. So today, we're gonna jump right in. So I have a little slogan for myself. So just others show you what to do, but I'll guide you there. All right, so let's get started. So it all start with like let's. I mean, looking at this model, yeah, it is a forge, but the implant is kind of like all over the place, right? Okay, and then you can see another example. There's you're right. I mean, we're from the lab. I mean, this photo is from, from on the internet, but really in the lab, we see a lot interesting models. Really, not to mention like something like that, right? Or even when the teeth is, you put it in the patient's mouth, you see this type of big ouch design, right? I mean, when the patient smile, the gum line shows, right? Something like that. Or even, when the, prosthesis, you take it down, do your maintenance, you see those, type of food storage down beneath on the intaglio of prosthesis, right? Or you can see like this photo, okay, this is a, if you look closely to the arch kind of like shift to the other side. And I mean, yeah, the midline shift and the occlusal plane is kind of a little off, right? I don't know if you can tell that, but if you look closely, make an imaginary line into interpupillary line to the occlusal plane, it's kind of like off a little bit, right? So it all comes down to the prosthesis, right? What is the good prosthesis, right? Is it like, look like very vivid, look like, so many characteristics within? Is that a good prosthesis? So if we know what a good prosthesis is, should be, then we know how to make the treatment planning correctly. And then I would love to run this video for you. So he's a pretty famous doctor, Dr. Robert Stanley. So he's talk about, what he found, in the his daily work. And I would love you guys to hear that as well. All right, so let me see me here. All right. So what Dr. Stanley, really told us is, really, when you look at the lab work, you will know the lab work is actually the processes itself is the outcome of our treatment planning and execution, right? So the really, the thing is to put it, implant in the right place. So in short, what's his main idea, is if you cannot place, a screw retain prosthesis, you probably are in the wrong place, right? So I mean, this is what his, main idea. So what we can get is so the really important thing is to place the implant in the right place. And then, the prosthesis is really just the outcome of our treatment planning and execution. So nowadays, because we have so much, technologies nowadays, we know where we can really plan where the restoration should go, and then we can go back to see the bone to see if the bone will allow us to get there, so we can achieve a real, restoration driven implant planning. And this is so powerful. So let's go back, to the bottom line. So what is a, let's say a clinically acceptable all-long X prosthesis, right? There are certain criteria with that, and then we won't be able to go all of them today, but I brought up three, thing we can go over today, and then we're gonna practice that in the treatment planning session later. So the first thing, so there are so many criteria, right? So let's see. The first thing is, restoration type. There will be FP 1, 2, and 3, right? And then we're gonna talk about restoration space, and then we will talk about screw access position for today's webinar. So, and then we're gonna practice on a live demo to see how that things work, right? So when we talk about, a restoration type, like FP 1, 2, 3, there's a very famous, literature. So that's written by Dr. Carol Smith. So this is Dr. Bajorjan. In his lecture, he's also talk about, when the patient, as a full-arch patient, right? There are different stages about, their defect happening. So the very first one is a teeth only defect, right? Just the missing teeth. And then when the teeth is missing, the bone will start to resorb, right? It will go, horizontally first and then vertically later, right? So you fall on to the next stage, which is, composite defect, right? It's not only the teeth, but certain amount of the ridge. And then if the bone just keep resorbing, it will just, become a not only the teeth defect, but also the soft tissue defect, but actually the bone defect, right? So the restorations just needs to be done at different stage, right? So based on 1, 2, 3, then actually teeth only, teeth and a little bit of the ridge, and then teeth and a lot of bone, defect. There are majority three type. And then this is an article is written long time ago, but it just tells us, very important one. This one is by Dr. Carl Mish. So this tells us FP1. FP stand for fixed prosthesis, right? Type 1, it's just replacing the teeth itself. So it's just the teeth missing part, right? And then the other one is FP2 is, when the ridge start to resorb, you kind of like getting a little bit of, soft tissue needs to be replaced as well. And then when you fall onto the FP3, it means a lot of bone resorption happened already. So we're not only to, replace the teeth, but we also need to replace some soft tissue, which is the pink as well. So there are different, um, defect when it comes to your full-arch fix. So this is the definition for them. Very important. So after we know that, we can jump to the next topic, which is the restoration space. Because, when we work on full-arch cases, There's so many component has to be inside, right? So that's just breaking down. So let's see the case right here. So if you see that, upper picture there, that shows, when the patient smile, I mean, it just show the that gummy smile, right? So that means, the restoration, I mean, aesthetic doesn't be considered, evaluate correctly before proceeding, as a, for large when even though there's no bone resorption yet, but you need to look at the patient because there will be a line called transition line. It's a line between the prosthesis to the patient's biological soft tissue, right? There will be a transition line there. So ideally you try to hide that transition line into the patient's smile, which is the lip, to help you to hide that. So if the patient smiles a lot, so you didn't see that, you didn't plan it right. So when you place a full arch fix on that, this is what you will get, right? And the other thing for a restoration space is when the restoration space is not thick enough, you got fixed bridge like keep breaking, and that's a nightmare for that. So let's talk about the restoration space. So what has to be into the prosthesis, right? So that if we break it down as a full arch, you can see in the bone there will be, of course, the implant itself, and on the implant is the abutment. Majority of time, it will be multi-unit abutment, right? So you will take about like 2, 3-ish millimeter away, and then on top of the abutment will be a tie base. So the tie base actually will be embedded into the prosthesis, right? And then it will also eat up your restoration space as well, right? About like five, sometimes even higher, right? And then of course you need to save some room for the processes itself, which is the pink or the white, the teeth or the teeth base, right? So this is if you do the cross-sectional view, this is what you will see. So if you do the math, to add them up all together, so from the top of the processes to the top of the implant, it requires like 13 to 15-ish, restoration space. So this is what we are looking for. It's not that hard to understand. Just like if you try to place a new refrigerator in your kitchen, right? You have to measure, if your kitchen is big enough for the refrigerator. If not, get a smaller refrigerator. Then if you have to feed a refrigerator, you have to make space for that before you purchase that, right? If not, it's gonna be a chaos. So just do your math, so before you put a refrigerator in your kitchen, same thing here, exactly the same thing. So that's restoration space. So the other thing we're gonna talk about is the screw axis position. So why is that matter? So let's see two examples. So you see the photo on the left side, all the implant is placed very, very parallel. So, I mean, you have to do a bar or whatever, to put it in. Or if not the case, you have to bulk a lot of, acrylic of your processor, the pin part, right, into the, palette. That's not comfortable, right? So that's too palatable. And then if you look at the right side of the picture, that's when implant placing too buckle, right? Your screw axis end up like very facial. That will become two issue. First, it doesn't look good, right? And the other issue is you have to bulk out. If you try to cover that, right, you have to bulk out your prosthesis, and your big prosthesis might look like not that good, right? I mean, this is what it is. Oh my God, this is real world situation. So we don't want that happen either. So what we need to do is to place the screw axis to where it should be. So what defines the position of a screw axis? There will be two major things. The first one is the position slash trajectory of the implant, right? The position of the implant or trajectory. That's easy to understand. The other thing is the position and trajectory of your multi-unit abutment, right? So usually multi-unit abutment will be straight as a zero, like 17 degree or it's 30 degree. And then they have, if these are internal hex implant, you have different, ways to rotate them. So all of them will affect the, trajectory, the screw axis in your prosthesis, and that matters. And we know why already. So why do we need to put a screw axis right on the arch, right? So the reason is very simple because, if you place the, screw axis right where it should be, you will have a very slender fixed hybrid prosthesis. So it really comes from an ideal screw axis. So that is really matter. So where is the, ideal screw axis? Meaning where are we targeting at, right? So that thing is actually, at the anterior. So we targeting at the singular, right? That's the most ideal, screw axis. And when you move back to the posterior, it will be the occlusal table of the posterior. So anterior and the singular at the anterior and occlusal table at the posterior. That's just, our goal. Whatever the bone, the condition is, if you place the arch, this is the teeth needs to be, and then that's where we're shooting for. That's our goal. If we shoot there, we'll have a very slender, very nice, prosthesis design. So this is an example from my mentor, Dr. Brendan Cover. So if you aim, this is the anterior case, right? If you aim the trajectory for the abutment about like anterior to the singular, you can see, this very nice, you know, continuous profile of your prosthesis. So there will be no foot trap, there will be no big shelf, right? And then the prosthesis won't be that bulky, right? So on the other hand, if you, put it very parallel, let's say like this one, so your prosthesis ending like a big shelf on your facial, right? On your palatal, you have a lot of bulked prosthesis in your palate. That is not comfortable. So this is not what we want. So that's what we are aiming for. All right. So, and then that's just the trajectory of the implant, right? So now we know we still have the multi-unit abutment, right? So what the multi-unit abutment does when it comes to the full-arch fix, the first thing is, it changed the internal connection into an external connection. So it allow, different unit to fit, the same, splendid processes seated down at the same time, like greater path of insertion per se, right? So, and because, some certain area of the bone has different angles, so we have different, angulation of MUAs to bring the prosthesis angulation back in certain degree. And then not only the angulation, the we still have to pay attention to the internal hex, right? So because the internal hex, when they rotate, we might not able to aim for the correct trajectory, right? We do have to, so the timing of the implant tells different stories. So we have to aim the implant in the right place, right? So there's a screw axis. So it's not, only the, mesial buccal. We're talking about mesial buccally, right? So let's talk about, mesial distally, right? Which is AP spread. So what is AP spread? So it starts with, A stand for anterior, P stand for posterior. So that's basically, the spread from anterior to posterior. So if you draw an imaginary line at the most anterior implant and another imaginary line at the most posterior implant, you put them all together, and then yeah, you draw another imaginary line, the green one right there. That is called AP. So right, so the AP spread, actually it tells us a very important thing is how much, cantilever we can afford, right? So we will talk about that cantilever a little bit because not only the upper but the lower as well. Most of the time for large patients, we don't have a chance to place implant at the back, right? So we usually have to put implant majority at the anterior space. So we have as a large fix, right? We have to extend a little bit like cantilever for the prosthesis, but that prosthesis has a maximum, you know, this distance. You can go unlimited. So the AP spread, the golden ratio is 1.5. If you draw that AP line and then just, multiply by 1.5, that's your maximum, cantilever that you can have. So it's not only for the prosthesis, it's also for the implant itself. Imagine like, if you're biting on the back, super strong force, like 100 Newton at the back, right? So your prosthesis, when you're biting here, it's kind of like working as a seesaw, right? So if you bite on the back, the anterior implant is kind of like, slowly being, like a seesaw effect. And actually, the implant in the middle works as a like a pivot, let's say, and then you place put a force at the back, and then the implant at the front just, slowly being taken out, right? That is not fun. So AP spread the cantilever has to be, within 1.5 times for that. So that's basically what's the three major thing I want you guys to get into, which is the restoration type, FP1 to 3 for teeth and bone and compound defect. And then the other thing is restoration space. How much is enough for you to fit a refrigerator in your kitchen, right? And then another thing is screw axis. It has to stay in a singular at the anterior, posterior at the occlusal table of the posterior, and the AP spread has to be good enough to support that, right? So that's three major takeaway for today, and we're gonna practice that later in a treatment planning session. And then that's for restoration, right? So that's our restoration driven. So we keep that in mind and then go to the implant planning, right? Later. So not only, oral surgeon come here will say, hey, the tissue is the issue, right? The space makes the case, but the bone sets the tone, though. I mean, so we have to know, if the bone is allowing us to do such planning. The bone is still very important. So we are actually basically when we look at an anatomy of the bone, we are looking at both the bone quantity and the bone quality. In short, is the bone good enough? I mean, the width, the length, good enough for the implant to fit. And the other thing is the bone is hard enough to get stability from. All right. So this is another, amazing doctor there. So this is Dr. Camaras. So he has a phenomenal literature talking about um, classification about full large implant placement, the treatment planning, where the implant could go, right? So this is, basically this is for our upper because we're gonna practice on upper later today. So there's another lower one as well. So basically, what he mentions in the literature will be the classification from 1, 2, 3, 4, 5, right? They're all totally in five, and then it will be different options. Basically, what it means, just different type of bone resorption, like when it comes to classification, number one, it's only two is missing only, right? And then you just add more less bone, less bone, less bone. What do you need to do, right? So the option A will be different numbers of implant. Then option B will be even tilted, angle it away, and then just different condition and just using different method to try to accomplish a full large fix. So today we're gonna practice on classification 3, option B, which is the traditional old long four. So basically four implant at the anterior, and in order to to reduce the cantilever, we will tell the posterior implant distally at the uh, platform level, and at the same time we will avoid the sinus cavity. All right, so let's move forward to the um, planning session. All right. Let's see. Let me share my screen here. All right. Let me, sorry, I'm gonna make some settings for myself. Change that. Still not able to share. Okay. Let's see if I can do it here for now. Right. So let's start this session. So here we see the patient here. I already import the CT scan for the patient already. And then today we're gonna do a full arch, fix prosthesis for the patient. So the first thing we're gonna do here is to see the patient in the right place, meaning we're gonna set, orientation for the patient. So this is, a RealGUIDE software. So here, it's just like, mounting your model digitally, right? We just want to see, it's not candid, all around, like, in the middle. Let's see if we can, we put the patient in the right position. And then like that, as a occlusal plane, and we're not candid, and then just apply. So the orientation just being set right there. And then the next step, we can, see different rendering. So this is for the bone. So you can drag that to change the threshold to about how much you can see. And then you can also show the soft tissue. So if we can drag that, right. So we can see the patient's nose and lips, all that information. Very useful. We won't deep dive too deep into, the processes design today, but the overall workflow for the fixed hybrid. All right. So the next thing is to import the STL file for the patient, right? So the first thing we're gonna import the anatomy. So this is the upper model there. So that's the upper model. And then, and of course, we'll do the merging later. So, and then let's keep importing um, the lower model. All right. And then the next thing, we're gonna import the prosthesis. So that's the wax up. So this is upper denture. So usually, so this you can see those three STO5 are, stay in the certain, coordination. So we don't have to do any merging, based on different STO file. But if not, we do have to, overlap each one of them. All right. So the first thing we're gonna, merge the upper model. So that's hit merging to DICOM and then just hit OK. And then so RealGUIDE, they have a AI function. What you need to do, just hit assist. You will just automatically put the model in the right place. And if you are new to guided surgery, this step is critical because all the deviation, the majority deviation coming from this part because we designed the guy on the model, but we plan an implant in the on the CT scan. So those two model has to be aligned correctly. I mean, very, very nicely. So this part, I am majority all spend a lot of time to make sure everything is right, right? So that's opera has been merged. So because that first one be merged, right? So the other thing we just keep pushing the same coordination and put all the model back together. So this one that's hit merge. just hit to, just make it the same as the anatomy. And then let's see, oh, that wasn't that one. All right, so let's see. That should be this one. All right, so you can see, the lower model just being occluded to that position. So we can change the color here. So it'll be easier for us to see different models. All right. So the next one is the denture design. So my colleague, has already designed the processes already. So we will use another webinar to talk about how to design, the processes correctly. So in order, to save some time, we just copy the position of whatever related, because when he export the file, everything is related together already. So for now, we just put everything there, and then hit next. And then here we're gonna draw the panel curve. So yeah, we can use the AI function to do so. So you just need to hit the maxilla. So you will just you can hit assisted. You will just automatically to put the bone in the right position, and then yeah, your occlusal plane midline should be correct, but usually it's not 100%. I'll still have to do some manual adjustment. Let's see what result we got this time. All right, so as you can see here, we're pretty close, I would say. So what I would do, just change the, this angle a little bit, and then let's see if the panel curve has followed the bone. No, not really, right? So we still have to adjust a little bit, right? So the AI is not that smart. Yeah, I mean, I don't know if that's a good sign. Nowadays AI just taking a lot of job for us, isn't it? All right, so next step. So you can hit here, to select a thicker thickness, so we can see basically everything, and then we can increase the vertical field of view so we can see basically everything that we need. All right, so next step. So the next step, so basically we just follow, the process on this column. So this step is for T set up because we have a, T designed already, so we can skip this part. All right. So now is the treatment planning time. So to do that, we can turn this part on, right? And then turn all these off, and then we just turn on the processes because this is restoration driven, right? So we need to make so of course you have to make sure the teeth is in the right place, and we will cover that in the next webinar. So for now, let's just say this we're happy with the teeth position. So the next thing is to place the implant, right? So we try to do a class 3 implant. So I'll do a tilted planning here. As you can see the angulation like that. Let's turn this off so you can see, right? So now we can try to place the implant there to avoid the sinus. And from this angle, because it's tilted, right, we will be allowing a good amount of bone to fit the implant. So let's try out that. All right. So, and then, yeah, usually this position, we will need a 30-degree angulation. And for the guided sleeve, we can select, put a D dynamic abutment solutions. So that's the guided sleeve for that. So let's just hit apply. All right, so the DAS dynamic abutment solution guided system is a universal one. So you basically can work with any major implant company, which is awesome, right? So super easy to use. So if you guys really into a guided kit, you should that thing should be in your list. All right, so that's that. So let's just say we're happy with that for now. And then this angulation, we can change the angulation of the multi-unit, and then we can make this transparent a little bit. So now we can really, in a 3D world to see how the implant looks, and then see, how the processes look, right? How cool is that? All right, so after that, let's figure out the other, other way. So here we can place another, tilted one, or if the bone allow us, we can place a straight one at this area. So let's see, it's almost like second bicuspid. So the AP spread should be pretty good here. So that just to practice as a, for the sake of practice, that just place as a, along four as well. So let's tell that and then click on the tooth number here. And then, yeah, everything looks good. Let's drop it. All right, so let's put the implant here. Of course, we're gonna make sure you stay within the bone, right? You can look at the, on the sides, the shell of the bone, which is cortical bone. In the middle, the darker gray area is the, cancellous bone right there. So we try to utilize, a buccal bone plate to, get maximum stability from there. So we can see, okay, we avoid the sinus, and then as well, how about our AP spread there? Wow, not bad. I would say, yeah, pretty, yeah. So the AP spread will be pretty good there. All right, so that's that. And the other thing we need to, make sure is the restoration space, the refrigerator that we talk about, right? So you start from the implant level, let's measure from there to the top of the procedures. We are about like 30 should be good enough. So this is a very good, restoration space. And then as you can see here, it's not only the teeth being replaced, but as well some, portion of that pink. So I would say this is a probably FP2 or FP3 type of restoration space, restoration processes right there. And then yeah, so the minimum implant for a fixed full-arch is about like four implants. Just like if you new to the field for now. So this one we can definitely use a shorter guy here, and then let's put it in to see how that looks. Oh, right. So because I still select a 30-degree, multi-unit abutment, as you can see here is way too palatal, right? So yeah, let's change that into a 17-degree to see how that looks. All right. So yeah, 17 degrees getting better, but we still, it's not at the singular yet. So let's see how we can do to address this, right? So to do that, we have to, angle it out, or we can use a straight, of course. So let me actually show you guys if we use a straight, what will happen. So if we use a straight, this is what we will have, right? So this one is coming too facial, right? We don't want that, right? So here, if we try to make this happen, we do have to angle it more, like this way, and then tell the apex of the implant more, posterior to aim for that, right? Some doctor is not liking, the when the implant too close to the buccal plate. So it's really, to this point, we can use a straight or a 17, just based on your, preferences. So if it's a straight, it's basically pretty much looking like that. I mean, that will work. But if you try to stay away from bone more, you can, use a 17-degree, and then now you have more room to play, right? Because it's torting restoration is facing more buckle. So now we can place the implant more stay away from the buckle, right? So the implant will be safer by placing, the trajectory like that rather than this, right? So that, this is the benefit of, digital planning. So you can use all the different parts. I mean, you can figure out this during, chairside, during surgery. But yeah, if you have the chance to do it digitally, I mean, why not, right? This is so good. So this spot here is, oh my God, see the bone is very thin right here. So we do, if we, use a straight right here, I mean, oh, this is a 17 as well. Yeah, that's good. So yeah, so we can face more like a, facing more like singular right there. So because we use a 17, so we can, hide the implant more at the posterior more, right? So that's very nice. So yeah, pretty much. Yeah, usually I'll spend more time, try to, figure out the best position for both implant and as well as the restoration, the multi-unit. But for now, we just try to, save some time for the webinar, right? So just, I'll just quickly, let's just say we're happy with the implant planning for now. All right. So it's not perfect yet. So just, but good enough. All right. So let's change the sleeve. So the good thing is, the dynamic abutment solution, the sleeve system is all built in RealGUIDE. So let's select that. So there will be no problem for us, to decide the guide that we work for, the guided sleeve that we work for. Right. We can change that into a dynamic abutment one. There you go. And then that's C. That's being changed. What about this guy right here? I think we're good on that. What about this? All right. So everything's so good right here. So that just say we're happy for that. So when we move on to the guide design, so the procedures look good, like AP, and even this side. Yeah, usually I'll try to make it more symmetrical, right? I mean, just and then let's go back to see. Oh, that's not fun. Don't do that. All right. So okay. So that pretty much like that. The AP spread is good, and then all of them are engaged good amount of bone, and at the same time are all away from the uh, non-vital anatomies, so we'll be fine. And then the next thing we proceed is the guide design, right? So we plan the implant based on the CT scan. So the guide design will has to sit on the anatomy, which is the tooth model, right? But yeah, now we have a problem here. So all the sleeve is sitting into the teeth, right? Then how can we make a, easily simplify a thing to make a guy out of it, right? I mean, so this sleeve is not hitting somehow, but it's hitting the teeth. What should we do, right? So in RealGUIDE, that would be pretty easy. So you just, strategically to see. So there are different type of guide, like two supported, mucosa supported. So for now, we just think, okay, we try to see the mucosa supported, but we're gonna save some teeth for our, guide stabilization there. So what I would do, I would try to, yeah, this canine, I'll keep it there because it doesn't touch anything, and I will keep this canine, right? Those two canines to stabilize, the whole orientation of the guide. All right. So to do that, I'll keep this canine and that canine. Other than that, I'll remove all the teeth, meaning digitally extracted them. So to do that, let's jump right in here into sandbox. So let's select this software, hit edit the object. And then, before we do, usually the good habit is to create a duplicate for that. But yeah, just save some time. So I'll use a lasso, to, circle the area that I want to, remove. So let's see. Oh, actually, the spines. All right. So that's that. So that's selected tools area. That looks good. And then we can select close hole and select invert cutting area and hit cut. So the software itself just will remove the area where the tools are, right? And then, yeah, you can see the sleeve is still within, and I'll teach you another trick how to, address that. So let's just keep removing all the other teeth, the muscle. Oops, it's actually the spine, right? Okay, so that's just we'll try to keep the canine so we can cut all these teeth out like that. All right. And then as he invert that and close hole, and then he cut. All right. Oh, dang, I just accidentally cut the teeth that I need to keep. Actually, the canine. Let's go back a little bit. Sorry about that. So let's try to do that again. I shouldn't remove the canine. That's an accident. You don't want it happening in a, surgical chair. So that's another good thing about, digital, right? You can always control Z anything. So good. All right, so let's try to cut till here. And we try to keep that canine because we need to use that to anchor the surgical guide. And then close hole and invert, and that's cut. All right, so that's been cut. So you can see here is not so clear. You can use another, cutting area tool to remove all that. That's an easy fix. Not like that. Let's try that again. All right, all right. Try that again. All right, and then RealGUIDE, they have a very nice, uh, editing tool. You can easily remove all the things that you need to keep, you don't want. Basically it's just like waxing knife on your hand, which is so nice, right? But you can see the sleeve is still within the model, and I'll teach you a way how to address that later. So these lax teeth to remove because the guided sleeve is in the way, so we have to take this guy out. All right. And then that's close out and invert and then cut. So the last T is just being removed. All right. So here's our master model for the guide, right? So we can always, whenever, sharp edges, we can smooth it now a little bit. And the guide will basically sits on this model, based on, the palette and then two canines. So it will be very stable. So that's hit and tool. So this is our master model where I mean, the guy will gonna sit on. All right. So you're gonna ask me, hey David, the guided sleeve is still within the socket. How you gonna make that happen? Oh, okay. So usually, when you try to do a full arch, most of the time to address that would be a stackable guy, right? You use a bone reduction guy, you remove the bone, and then you stack your drill guide so it can sit down properly. Now, but so we try to do a simplified guide right here. So basically, we just try to do a tooth and mucosa mixed supported guide right here. So we're not gonna do that. But how are we gonna address that? Easy. So when you work with desk guided sleeve, as you can see here, let's see to this let's say let's move on to the interior one. So okay, so the sleeve is still within the soft tissue. That's not okay. But the good thing is, the guided desk guided sleeve has very, good flexibility for you to design different offset for your implant. So all you need to do is look here. This is the, sleeve distance. You just keep increasing them until it's free from the model, right? So now we just raised the sleeve by 9. All right, so the sleeve, now you go back and say, whoa, life is good. But you come back to me and say, hey, David, wait, if you raise the sleeve, doesn't that implant being raised as well? So that's another cool, feature about that guided sleeve. Yeah, actually, when you drill, you just, it being raised by 4, like from 5 to 9, it's raised by 4, right? You just select a drill, for example, it was 10. Now you just drill for 14, then that will be exact the same depth. And when you, do the, implant delivery, you just use a different offset height. There will be different height of implant mount. So even though the sleeve has been raised, but when you drive the implant into the guide, the implant will still stop at exact position where it should be. That's amazing, right? So much freedom. As a surgical planner, I love this feature. So that just raise it up from 5 to 9. I mean, when we raise a sleeve, so usually I would just, use it the same prolongation, just easier, for the surgeon to do the surgery. So let's see this guy. Let's keep raising it. This is so beautiful. I love this. So this is a 9. We can, this is a 9.5. Let's put it back a little bit. I mean, we can keep increasing it. Oh, yeah, we do have to. So let me see the depth of the implant. All right. So this is the back example, right? So actually, when you, after planning implant, you shouldn't touch it anymore. But now you can see when the need of the design, yeah, okay, you can change the trajectory. Now it's free, but not a good thing to do because we're losing AP spread right there. So yeah, for now I just have to keep increasing until I'm free from that area. So yeah, I mean, oh my God, this is crazy. Yeah, I can up to 12 millimeter. Oh my God. So how many I got? I increased by 7. Oh, oh my God. Hopefully it's not too much. I mean, yeah, ideally you don't want to increase too much because the further it what you be, if the further they are, the greater the projection error, which is the accuracy of the guidance surgery will decrease a little bit. So just pay attention to that. Just, increase, I mean, like good enough amount, just not too crazy, right? Let's just say we're happy with for now. So, and then let's try to play this guy right here. So this guy, we don't have to do too much. So let's just see, increase the height for the sleeve until it's free from the model. Yeah, so it's increased by 10, not too crazy, right? All right. So let's just say we're happy with that. So for now, it's all clear, right? All the sleeve is clear from the model. So the next thing is to design the guy to hold the sleeve as a sitting jig, to make the surgery happen. So to do that, let's move on to the next step, which is the guide design. All right. Okay, so the first thing, this is our master model. I will just, look at from a facial view to make sure it didn't cancel. This step here is critical. We're trying to define a path of insertion of the surgical guide, right? So let's rotate that to see the survey line is, covering all the profile of two canines as well as the palate and the ridge, right? So let's say we're happy with that. So that just set, the insertion direction. So the software will just block out all the undercut, and then we can generate undercut. So you will automatically generate an undercut model, and then the undercut model will be the master model to see the surgical guide on, right? All right. Okay, so next. So here you can toggle this on, allow you to see all the sleeves position, and then we can use a spine tool to select the area where your surgical guide is gonna support at. As you can see, there's a groove right there. You can, and that's a hint telling you the patient wearing a posture for a long time. So if you see that, the mucosa supported guy sitting there will be super solid. Just trust me, you try it, you will love it. All right. So just covered all these areas. And then, yeah, just to make it look a little bit nicer. Let's see here and there. There are so many designing details to cover, but all right. So if we're happy with that, just hit create. So you will just generate the guide support holding the sleeve in place, and then just will be a surgical guide then sits on this on the car model. All right, so this is our surgical guide model. So what I usually do, I will scope those guys out so you won't stop you from sitting the guides out. So this is RealGUIDE, very nice software. We can even turn the model out, to smooth it out a little bit, right? This is so cool, right? All right, I love this. And then we can even open a window on the canine area to make sure the guide is sitting properly. This is called inspection window. But don't get too greedy, right? Because this is the only two teeth you're gonna sit on. So if you cut too much, you will lose its chance to stay stable there, right? All right. So I will say pretty much this gonna be fixed. How about here? And then this is, the extraction model area. Usually I will just push it down a little bit more so we won't have any, potential issue when the guy is not sitting down. All right. Next step. Okay, so for now, we can see here the guy had just been generated. And then yeah, we can look at it. So you is we plan all the implant and the guy just sits on the let's change the transparency a little bit more. Sits on two canine and then majority on the palate and all around the ridge. So you can see the guy just sitting really nicely, right? And then just a super easy way to do the guide design. So we figured out, where the implant has to go as a cingulum and the anterior, occlusal table of the posterior, gray AP spread. Is pretty good, like symmetrical everywhere, right? I mean, yeah, we just convert everything we learned today into a real designing session, and then use a very easy way, to simplified way as a like just take out the teeth, keep two canine there, right, and then just see the teeth slash mucosa supported guy on top of it, and then we raise the sleeve, and then we can still use the different the offsets implant driver after the osteotomy. We can still see the implant at the exact position that we planned. Cool, right? So this is the planning session for that. Let me stop share from here and let's go back to our main screen here. Share keynote. All right. All right. Continue to share. All right. So basically, this is that's just our demo about how to make all the thing together. So we learn, there will be two supported, mucosa supported, which is those two easiest way to see the guide on, right? And then basically, this is what we do today to make the guide happen. And then yeah, that just wrap up a little bit. So we today we learned about restoration type, the FP123, to respond to teeth only defect all the way to composite defect, right? And then we talk about the restoration space, not only the implant, but on top of implant will be multi-unit abutment, and then tie base, and your material for your prosthesis, right? And then there will be screw axis. This is one is big, right? So you want to place it right. Your implant has to be the right place. And then your multi-unit abutment has to be in the right place. And then you gotta, increase your AP spread to in order for you to design the prosthesis, made the correct prosthesis correctly, right? And then we learn about how to evaluate the bone, right? And then we studied, Dr. Kamara's bone classification. That's what we practice. The traditional all-on four fixed prosthesis into real practice, right? So that's pretty much for today's webinar. So because we're gonna hold this webinar as a monthly basis, so we are calling for cases. So if you have any cases you want to talk about, you want to discuss about, you want to play around, please feel free to email all your CT scan and ST file to me, and then we can, run this webinar as a study club that's learn together. All right. So this is my information. If you need anything, you have any questions, or you want to know more about, the DAS guided kit, just feel free to reach out to me. And then, yeah. So thank you so much for you guys to attending the webinar tonight. So wish you all have a good night and see you next time.